Appendix 15 of Edison, His Life and Inventions. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information, or to volunteer, please visit LibriVox.org. Recording by Jerome Lawson, January 2008. Edison, His Life and Inventions, by Frank Lewis Dyer and Thomas Comerford Martin. Appendix 15. Kinetograph and Projecting Kinetoscope. Although many of the arts in which Edison has been a pioneer have been enriched by his numerous inventions and patents, which were subsequent to those of a fundamental nature, the so-called motion picture art is an exception, as the following, together with 3 other additional patents, see footnote 30, comprise all that he has taken out on this subject. United States Patent Number 589168, issued August 31, 1897, and reissued in 2 parts, namely number 12037, under date of September 30, 1902, and number 12192, under date of January 12, 1904. Application filed August 24, 1891. Footnote 30. Number 491993, issued February 21, 1893. Number 493426, issued March 14, 1893. Number 772647, issued October 18, 1904. There is nothing surprising in this, however, as the possibility of photographing and reproducing actual scenes of animate life are so thoroughly exemplified and rendered practicable by the apparatus and methods disclosed in the patents above cited, that these basic inventions in themselves practically constitute the art, its development proceeding mainly along the line of manufacturing details. That such a view of his work is correct, the highest criterion, commercial expediency, bears witness. For in spite of the fact that the courts have somewhat narrowed the broad claims of Edison's patents, by reason of the investigations of earlier experimenters, practically all the immense amount of commercial work that is done in the motion picture field today is accomplished through the use of apparatus and methods licensed under the Edison patents. The philosophy of this invention having already been described in Chapter 21, it will be unnecessary to repeat it here. Suffice it to say by way of reminder that it is founded upon the physiological phenomenon known as persistence of vision, through which a series of sequential photographic pictures of animate motion, projected upon a screen in rapid succession, will reproduce to the eye all the appearance of the original movements. Edison's work in this direction comprised the invention not only of a special form of camera for making original photographic exposures from a single point of view with very great rapidity, and of a machine adapted to effect the reproduction of such pictures in somewhat similar manner, but also of the conception and invention of a continuous, uniform, and evenly spaced tape-like film, so absolutely essential for both the above objects. The mechanism of such a camera, as now used, consists of many parts assembled in such contiguous proximity to each other that an illustration from an actual machine would not help the clearness of explanation to the general reader. Hence a diagram showing a sectional view of a simple form of such camera is presented below. In this diagram, A represents an outer, light-tight box containing a lens, C, and the other necessary mechanism for making the photographic exposures. H1 and H2 being cases for holding reels of film before and after exposure. F, the long, tape-like film. G, a sprocket whose teeth engage in perforations on the edges of the film, such sprocket being adapted to be revolved with an intermittent or step-by-step movement by hand or motor, and B, a revolving shutter having an opening and connected by gears with G, and arranged to expose the film during the periods of rest. A full view of this shutter is also represented, with its opening, D, in the small illustration to the right. In practice, the operation would be somewhat as follows, generally speaking. The lens would first be focused on the animate scene to be photographed. On turning the main shaft of the camera, the sprocket G is moved intermittently, and its teeth, catching in the holes of the sensitized film, draws it downward, bringing a new portion of its length in front of the lens, the film then remaining stationary for an instant. In the meantime, Through gearing connecting the main shaft with the shutter, the latter is rotated, bringing its opening, D, coincident with the lens, and therefore exposing the film while it's stationary, after which the film again moves forward. So long as the action is continued, these movements are repeated, resulting in a succession of enormously rapid exposures upon the film during its progress from reel H1 to its automatic rewinding on reel H2. While the film is passing through the various parts of the machine, it is guided and kept straight by various sets of rollers between which it runs, as indicated in the diagram. By an ingenious arrangement of the mechanism, the film moves intermittently so that it may have a much longer period of rest than of motion. As in practice the pictures are taken at a rate of 20 or more per second, it will be quite obvious that each period of rest is infinitesimally brief, being generally 1/30th of a second or less. Still, it is sufficient to bring the film to a momentary condition of complete rest, and to allow for a maximum time of exposure, comparatively speaking, thus providing means for taking clearly defined pictures. The negatives so obtained are developed in the regular way, and the positive prints subsequently made from them are used for reproduction. The reproducing machine, or as it is called in practice, the projecting kinetoscope, is quite similar so far as its general conditions in handling the film are concerned. In appearance it is somewhat different. Indeed, it is in two parts, the one containing the lighting arrangements and condensing lens, and the other embracing the mechanism and objective lens. The taking camera must have its parts enclosed in a light-tight box because of the undeveloped sensitized film, but the projecting kinetoscope, using only a fully developed positive film, may, and for purposes of convenient operation, must be excessively open. The illustration, Figure 2, will show the projecting apparatus as used in practice. The philosophy of reproduction is very simple, and is illustrated diagrammatically in Figure 3, reference letters being the same as in Figure 1. As to the additional reference letters, I is a condenser, J the source of light, and K a reflector. The positive film is moved intermittently but swiftly throughout its length between the objective lens and a beam of light coming through the condenser, being exposed by the shutter during the periods of rest. This results in a projection of the photographs upon a screen in such rapid succession as to present an apparently continuous photograph of the successive positions of the moving objects, which therefore appear to the human eye to be in motion. The first claim of reissue patent number 12192 describes the film. It reads as follows: an unbroken, transparent, or translucent tape-like photographic film, having thereon uniform, sharply defined, equidistant photographs of successive positions of an object in motion as observed from a single point of view at rapidly occurring intervals of time. Such photographs being arranged in a continuous straight-line sequence, unlimited in number save by the length of film, and sufficient in number to represent the movements of the object throughout an extended period of time. End of Appendix 15. Recording by Jerome Lawson, January 2008.